Hey everybody, welcome back to the channel. This is Vamsi Reddy, and today in this lecture we are going to discuss about linear algebra concepts. And in this concepts, today topics are what is mean by vector and operations of the vectors. So let's move into that depth. You can understand each and every concept of what is exactly the vectors and the scalar properties of the vectors. Everything you can get clear about this section. Okay, let's move into that. And today what exactly the meaning of vector. So vector is a array of numbers. So there is a two types of vectors like magnitude and directional. So here the magnitude vector means the length of a line between the 2 points is called a magnitude of a vector. So on the next one there is a directional vector, and the direction of a displacement of a point A to B is called a direction of a vector. So this is the two types of vector. Here the vector is denoted by lower bold lowercase on the top of the lowercase. It is a symbol of array. So it simply we can say that it is an array symbol. So here the example of vector. I am storing the in the A vector A. I am storing the 3 comma 2. So this is one of the example of the vectors. So let's implement in the graphical method. Here the graphical method of where we have considered the x-axis and here the y-axis, and 1 2 3 4 5, and the y-axis also 1 2 3 4 5. So we have taken that 3 comma 2. So here the 3 comma 2 functions means 3 comma 2. Here it will occurs here. So it is means it is an x, it is a y. So that's why where x axis I have taken the 3 and y axis I have taken the 2. So this is a vector, and we simply draw a origin line. So this is a vector, and which is straight arrow color. And there is a one more thing. So how we can find the length of a vector. So this is one of the important topic, how to find the length of a vector. Length of a vector. How to find length of a vector. So this is another topic. Let's discuss about how to find the length of it. Simply we have a one problem, one formula for the finding of n number of length of a vectors. So there is a simple formula is mod of a equals to, it is a vector defined, mod of a equals to root of vector 1 a square plus vector 2 a square plus, and so on, vector and a square. So this is a formula of finding dimensional vector, length of n dimensional vector. Simply for this case, we can consider the, for this case simply we can how to find the length of the vector for this case. It here means a bar is equals to root of by using the Pythagoras theorem. Like also we can find let's draw the Pythagoras theorem here, and we calculate this. What is mean by the Pythagoras theorem means x square equals to side square plus side square. Here x square equals to one side we have 3, one side we have 3 and another side we have 2. So here the 2 and here the 3. 3 square plus 2 square, h square equals to 3 square 9 plus 2 square 5, or h square equals to 9 plus 14, and h equals to root 14. What is the value of root 14? Approximately it takes something of value of h equals to 2 point something. So it is a value of h, so it is approximately 2 point something. and this is a value of Pythagoras theorem. So like this we can find this length of the vectors for the individual or n dimensional things. So this is a n dimensional things for n dimension. This formula is belongs to n dimension. Okay, I think so you have understand about this topic, what is a vector, and what is how to find the length of the vectors. Let's move into the depth about what is operations of vector, and the next topic is operations of vectors. So each and everything materials is provided in the description. You can go there and you can verify how the working is going on. Okay, and next topic is operations. Operations. Operations on vectors. So first operation we have considered that addition operation. Let's add the two vectors. Addition means adding of two vectors or more than two vectors. So first operation is addition operation. We are performing the addition operation on vectors. Addition operation. Let's just consider an example. Here the example I am giving, where a bar equals to, where a bar equals to 2 3 comma b bar equals to 3 2. So let's add this to two vectors, like c bar equals to a bar plus b bar. Yeah, I'm adding the two vectors like that, and c bar equals to a bar plus b bar. So here this c bar equals to, and I'm taking the a bar values 2 3 and the b bar values as 3 3 2. So I'm adding the two vectors, like we have simply in the lower level education we have learned how to add the two numbers, like that only we are adding. And c bar equals to 2 plus 3 and 3 plus 2. The answer is, here the answer is 5 5. Thus this is a simple how to add the vectors, like c bar equals to 5 5. So it is simple. So it's look like a symbol, and here the 5 is an x-axis and another 5 is an y-axis. Let's represent it in the graphical method, like here it's an x-axis taken as x-axis and a y-axis. 1 2 3 4 5. 1 2 3 4 5. Let's represent in graphical method. So here the, it's not working color on, I'm taking yellow. Yeah, this is a c value, c bar value. Here is a c bar value. So simply we have apply the operation of vectors for adding operation, and we have represented in the graphical method also. It's a graphical method. Graphical method we have written. And the next operation, let's move into that. Next operation is subtraction. So we have discussed about the subtraction. Yes, my handwriting is very bad, please try to understand that. Next operation is subtraction. As simple as we have done this operation in addition operation, like in addition we have add the two numbers, like that only in subtraction we subtract the two numbers. And here example I will give an example that you can clearly understand about that. Here the example is, here the example is a bar equals to, that's an a bar, a vector equals to 3 2 and b is equals to 1 1. I'm taking a is equals to 3 2 and b equals to 1 1 and c bar equals to subtraction. I'm doing the subtraction on this. So here the a bar minus b bar. So c bar equals to, I am applying directly, 3 minus 1, 2 minus 1, where it equals to 3 minus 1 2 and 2 minus 1 1. So the output and the answer of this c bar equals to 2 and 1. So let's move in graphical method. You can clearly understand how the graphical method works for this. It is an x-axis and it is an y-axis, and 1 2 3 4 5, 1 2 3 4 5. So here it is an x, and it is an y. So x-axis I am taking 2 and y-axis it is a point where the subtraction of c bar, c vector c, is a point where the vector c has occurred. And this is the second operation. And third operation, let's move into the third operation. And the third operation is a vector scalar multiplication. So it is a simple vector scalar scale multiplication, the scale multiplication. Okay, and this thing, and let's give an example. You can clearly understand about this vector scale multiplication. So let's consider an example like a scale a equals to 2 and b equals to 4 3. So simply we have used the formula of a into b bar. So this is a formula where here the a is a scalar, where a is a scalar and b is a vector. So multiplying of scalar and vector, we perform the operations. So here the multiplying a scalar and vector, find the c bar equals to a into b bar. So I am telling like the c bar equals to b bar like that, and where c is equals to 2 into 4 3. So I need to multiply this thing and with this and this is finally we get an answer. 2 4s are 8 and 2 3s are 6, and finally we get an answer as a 8 6. So this is a vector scale multiplication and vectors properties of the vectors. And there is some more additional properties for vectors like a bar a into b equals to b into a. So we can perform like this also some of the properties. And the next property is a into b equals to b into a. So like this there is some of the properties like addition of a vector is cumulative and associative, and the dot product of two vectors is a scalar and lies in the plane of the two vectors. And some of the things like there is we can multiply in dimensional. So previously I have discussed about the n dimensional methods, like here I have given a 2D dimensional. So it is an 2D, and we can perform the operations of 3D also, like a is equals to 3 2 1. So here the 3 is equals to x, and 2 equals to y, and 3 equals to z. So in data science there is a huge number of data dimensions to calculate the values, and for this is the concepts what the internally have occurred in the methods. So for the for a brief expression, so you can understand there is a in depth of algorithms there is a huge amount of dimensions are calculating linearly and vectorly. So and this all about the video, and I hope you are understand, and this material is provided in the description, have a link in it, and please try to watch that and download it. And okay friends, bye bye, take care.